So finally, we will look into estimation of our co-integration relation. We know already how to test for the absence of co-integration, but what if we now detect co-integration based on this test? How can we estimate our co-integrating vectors, and what are the statistical properties of our estimator? Also here, we will do these derivations only for the case of IID errors. Let us start from this co-integrating setting, where we make use of Phillips triangular representation. We assume that the error terms are independent and identically distributed, and we rule out any dependence between them. Also, let us consider the case with only two variables, x and y. We start, of course, from regressing y on x, and we get the least squares estimator from that regression. After plugging in the DGP for y, we arrive at this form. Now, in order to determine the asymptotic rate of convergence for beta hat minus beta, we need to introduce the correct scaling in the numerator and the denominator. Now, we've seen this many times until now. For the numerator, we need scaling by 1 over t to arrive at this limiting distribution. For the denominator, we need scaling by 1 over t squared to arrive at this limiting distribution. Putting these scalings together, we actually see that the asymptotic rate of convergence is t, not root t from the classical regression case. So beta hat is converging more rapidly to the true population parameter. What about the test statistic? Well, again, just start from its definition. Estimator minus quantity under the null divided by the standard error. And in the next step over here, I already introduced the appropriate scalings for all of the terms. Then I just plug in the expression for t times beta hat minus beta, which you can retrieve from the previous slides. And we derived already the limiting distributions of all terms involved. Only here the variance of the residuals is left, but we verify its probability limit in the tutorial. And we can again simulate from this test statistic, which now contains two Brownian motions. Now, what are some concluding remarks? Well, note that the derivations here were extremely simple, since we only considered two time series and no dependence between the error terms. We also looked only at a single co-integrating vector, since we can maximally have one co-integration relation for two time series. But can we relax all of that? Well, yes, people have extensively looked at this, and I've summarized here all the situations on this slide for unit root tests, co-integration tests, and estimating a co-integrating vector. The tests in bold, we considered in class. So for the unit root test, we did all of the work. We verified the IID case and also the cases for serial correlation with the two corrections involved. This week, we only zoomed into the IID case for the error terms, since the expressions were already quite long enough to still fit on the slides. You have here the other cases if you want to look at them in more detail. Now that brings us also to the end of this lecture. You should now have everything in place to prepare for your upcoming tutorial. Good luck.